Hello, ladies and gentlemen. Welcome to Unit 6. This is an intro to organic chemistry. And organic chemistry is basically working with things that are organic or organisms on our planet, things that are usually have living structures. And the backbone to all of those things are carbon chains. So when we're talking organic chemistry, ladies and gentlemen, we are going to be talking a bunch of carbons stuck together, attached to a bunch of hydrogens with maybe an oxygen thrown in here and some nitrogens. That is organic chemistry. There are other things, but this is pretty much the gist. Long carbon chains and kind of how they interact with things. So that's what we're going to be working with. So let's just do a little bit of a review from last class that we were working on. And that is how to draw a stick structure. So we kind of had Lewis structures, and stick structures are very similar. But with carbon chains, the carbons, if you remember, are always going to be a central atom. So you can see that this carbon here, based on the shape, looks like these two hydrogens are attached to that carbon, and these two hydrogens are attached to this carbon. And since this is one big compound, all of it has to be connected together. So let's connect it together. So we're going to have a carbon. Now you can draw your lines up to the side. I'm going to draw it like it's actually drawn because I know what the final shape is already. All right, and I know the angle of the bonds and all that. So I'm going to draw it like this. So you have that carbon is going to be attached to these two hydrogens. And then you're going to have another the other carbon attached to the carbon and these two hydrogens. This would be our general stick structure. And then as we just look, we know that hydrogen wants to have only 2 electrons in the valence, and it has the 2 right here. Carbon, which you're going to learn right now, and the faster you memorize this, the better you're going to be. Carbon always wants to have 8 electrons, always wants 8. And since each bond has 2 electrons, carbon is always going to want to have 4 bonds. And if you can go, yep, carbon wants 4 bonds. And remember that idea? This gets so easy for you. So as we look here, the carbons aren't happy. So let's figure out why. All right, so we have how many valence electrons? Carbon has 4. With that hydrogen, that's going to be 2. With that carbon, it'll be 4. And with those hydrogens, 2. So we have 4, 8, 10, 12. So we have 12 valence electrons total to use. And you can see we've already used 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've already used 10, which leaves us 2 valence electrons to distribute. And since the hydrogens are happy, we would distribute those on one of the central carbons. Now this carbon is happy, but now this carbon is not still. So we would have to share those electrons. And all of a sudden, I'll change the color just to make it there. So now we would have that double bond right there. And we would just erase those 2 electrons. And just for convenience, you can leave that little arrow there saying, oh yeah, I shared some electrons. Perfect. You want to get rid of it? Perfect. And this is known, ladies and gentlemen, as a stick structure. Okay? Stick structures are very, very stick structure. Very useful to use. All right? So I'm going to pause and we're going to move on. Okay, so now what we're going to be doing, we're going to be working on changing compounds. Well, not change compounds. We're going to be working on taking formulas from one form. This, for example, this C3H8, and we're going to be changing it in a different form so it's easier to use. So what we're going to do is we're going to get to a stick structure. We're going to make one like we did earlier. That's kind of close to what the Lewis structure is. We're going to change it to what's called a skeleton structure, where you're just using the bones. And I'll talk to you about that. So basically, we're gonna go through these 3 little sets of directions here. All right. But the first thing we want to do, we want to draw out this structure right here. This says C3H8. Now we know each carbon needs to have 4 bonds to it, and we know all the carbons are going to be bonded. And so I'm going to sit there and I'll just do it for you. And there we go. This would be the stick structure for C3H8. You can see Whoa, mama. You can see the 3 carbons are all connected in the middle, okay? And then I'll change each color as we go. You can see that this green carbon here is connected to these 3 hydrogens. And then the other carbon on the other side, this blue one, is connected to those 3 hydrogens. And this carbon in the middle, we'll call that the yellow one, is connected to 2 hydrogens. So you can see these 2 hydrogens are connected to that carbon. Now, if we take a look, we can see that each carbon still has 4 bonds. One, whoops, let me change the color on that one. There's this carbon. So the red carbon has 1, 2, 3, 4. This middle carbon, whatever color that was, I don't know, green or something. 1, 2, 3, 4. And then this last carbon, we'll make it blue. This one has 1, 2, 3, 4. So you can see that the carbons are attached. So what that is that these are all going to be forming carbon chains, right? Or they're going to be forming carbons kind of making circles, all right? Or these compounds where the carbons are all locked and these cyclical shapes. So this is perfectly acceptable as well, all right? And we'll just show that this carbon right here, that's probably the wrong color, but very quickly, this carbon here has how many bonds connected to it right now that you can see? It has 2, but we're going to find out later it's going to have more, all right? So let me get rid of this for you. And now let's keep going. Now, ladies and gentlemen, what we're going to have now is we're going to take a look at some other ways to write compounds. So this is what we call the stick structure. And we're going to base most of what we do off the stick structure. But if we want to, we also can have this structure here, this formula structure, which breaks down the compounds very easily for us to see. You can see that this says this carbon with the 3 hydrogens, right? This carbon, whoops, this carbon with the 3 hydrogens right here in red are the same as these 3 hydrogens here. And it says there's 3 hydrogens bonded to these CH2, which is bonded to the CH2. And lastly, that last CH3 right here is bonded right here. And so this is just another way to write it, but we can see that those 3 carbons are bonded together. So we could either write it as a formula, C3H8. We could write it as a stick structure. We could write it as this formula style, okay? Or this last one that we can do, ladies and gentlemen, is very similar, right? But it is the same, but just doesn't show the bonds. Now, I find that this one is the easiest, or one of the easiest ones to use, much more than this, because on this one, you're like, oh, where are all the hydrogens and everything? And then this one is actually a little bit better, and then this one's even better. So all of them serve a purpose, all right? Now, what we're going to be learning today is how to write a skeleton structure, and I'm going to take you through that. A skeleton structure, what we're going to do is all of the C's are going to become dots and corners, okay? What does that mean? You'll see it in a little bit. When we're drawing our skeleton structure, we're going to ignore the hydrogens. So we're not going to pay attention to the hydrogens that are connected to carbons. So these hydrogens, we won't even recognize those. And then we will draw all other atoms as well. So first things first, right? I'm going to call this one carbon 1, carbon 2, and carbon 3. And I'm going to draw it right here for you. It says that each carbon turns into a dot. So the hydrogen is going to turn into a dot. That would be hydrogen 1. And this would be hydrogen 2. And then what's going to happen is we're going to connect those together. Now, a lot of times people want to draw this in a straight line. I'm going to ask you to start going up at an angle. So this will be it. You can see the difference. So that will be carbon 1 and carbon 2. And then we have a third carbon right here. This will be carbon 3. Now, the carbons exist, okay? at all the corners and all the end points, unless something else is there. So this is carbon 1, carbon 2, and carbon 3. This right here is propane. The name of this is propane. All of these are propane. They all have 3 carbons, they all have 8 hydrogens. You can draw this one right here by going like that. Boom, that's the chemical skeleton structure for propane. Yes, there's still hydrogens on there, but we don't draw them. This is an easy way to draw out formulas. You can just say, 3 carbons, we're done. Okay, this is what you're going to be doing today on your activity. I'm going to take you through 2 more examples, and then you're on your own. It's very straightforward. Okay, so let's move on. All right, so let's go to our next example, which is right here. So let's draw the skeletal structure for this compound. Okay, remember, the C's become dots or corners. You don't draw the dots forever. You just kind of do when you begin. You're going to ignore all hydrogens that are connected to carbons. Is this hydrogen connected to a carbon? No, that hydrogen is not connected to a carbon, which means it doesn't fit that rule. We will be drawing in that hydrogen. Okay? So only ignore them if they're connected to carbons. So very quickly, we find the chain, and we can see this is a 1, 2, 3, 4 carbon chain. There's carbon 1, carbon 2, carbon 3, and carbon 4. And we have to draw that out. And it would look, I'll draw it right here. It's going to look like this. I mean, in theory, you have a starting point, and there's your second carbon if you want to. That'll be carbon 1 and 2. Then there's carbon 3. And then over here is carbon 4. Now, each one of these need 4 bonds. 1, 2, 3, 4. And you have it. 3 hydrogens, and then the bond to the carbon. So on bond number 1, on carbon 1, we have 3 hydrogens. On carbon 2, we have 2 hydrogens. On carbon number 3, we have 1 hydrogen and then 1 oxygen. So we're going to have to put that in. And so I'm going to draw a line right here. And I'm going to write an OH. It needs to be written in that order. Don't write HO over here, HO. It needs to be written as OH because it's the O that's attached, okay? So this would be carbon 3. And what are we going to do on carbon 4? On carbon 4, we're going to make a double bond. So we're just going to, and I can do it pretty much in any direction, but you just don't want it, you do not want that because there's no defining change in shape. So you can pretty much go in any direction except for straight out because you want to show that there's a change. So there would be that, and then there's the double bond. And there's our oxygen. So this would be carbon 1, 2, 3, and 4. This is carbon 1, 2, 3, and 4. Carbon 3 has an oxygen attached. Carbon 4 has a double bonded oxygen, right? And so what do we not draw? We don't draw the hydrogens. This would be the skeletal structure. So let's move on, ladies and gentlemen, okay? Let's move down the page. Ladies and gentlemen, what we want to do, let's just review. We're going to draw the skeleton structure, which is just the bones, just the backbone. So we're going to have the carbons are going to be the corners and the little dots on the ends. Ignore all hydrogens connected to carbons and draw all other atoms. So we could take a look and we'll say, okay, find the longest carbon chain. There are rules about where to start, but I'm not going to worry about that right now. So there's 1, 2, 3, 4. We have 4 carbons all connected in a row. All right. So we're going to have 1. Oh, geez, what am I doing? Sorry. You have that right there. How many carbons are there on this line right now? That's right. There's 2 carbons. So this is carbon 1 and carbon 2. And then we draw carbon 3. That'll be carbon 3. Then coming up here will be carbon 4. What's attached to carbon 1? Just hydrogens. Ignore it. Carbon 2, just hydrogens. Don't worry about it. Carbon 3 has a double bonded oxygen. So we're going to draw a double bonded oxygen. Carbon 4 has a triple bonded carbon bonded to a triple bonded nitrogen. So we're going to draw a triple bond. 1, 2, 3, and it goes to an NH. Wait a second, Mr. P, why are you drawing that H? Because the rule says ignore hydrogens only if they're connected to carbons. And this hydrogen is connected to a nitrogen, so we're going to draw it. Ladies and gentlemen, this would be the skeletal structure. All right, I'll do one more example with you and then let you go. All right, ladies and gentlemen, so let's take a look at this last one that we're going to do. First thing we're going to do is we're going to find, I usually find the longest carbon chain, but it really doesn't matter. It's probably going to be easier for you guys just to count it straight across. So that's going to be 1, 2, 3, 4, 5. So there's 5 carbons going across. And then you'd have like carbon A, B, and C, just so we can keep track of it. Okay? So let's see. Here we go. So let's draw. So we're going to draw carbon 1 and 2, and then carbon 3, then carbon 4. So there's 1, 2, 3, 4 carbons so far, and then carbon 5. Now, I put this on the 3rd carbon on purpose. And the reason is that things don't have to look exactly like they look here, because these are carbon chains and they're moving around in space. It's like this pen. You can't, oh, whoops, sorry, the pen, it's upside down, so it doesn't, well, no, it's going to be just fine. It's still a pen, even though it's upside down. So then what's going to happen is you look at carbon 1, carbon 2, carbon 3, that's carbon 1, carbon 2, carbon 3. And then what's coming off of carbon 3? You have 3 carbons coming off. So you just have to go 1, whoops, that's not a very straight line. So then you just go 1, right? Because that's still carbon 3. So this will be the carbon A right here. Okay, that'll be carbon A. And then you draw B, and then there'd be your C. So this would be the 1, 2, 3, that carbon chain, just like the one we did at the beginning. Because really all this is right here is another propane molecule that we did in the first example. All right, so this would be carbon 1, 2, 3. There's carbon 4 and 5. I don't want to put that in. All right, I'll put it here for 4. And now what do we do? What's attached to carbon 4? An F, a fluorine. So we draw a line, we draw fluorine on it. And then we leave this carbon 5 alone because all it has on it is the 3 hydrogens, and we ignore those 3 hydrogens because they're attached to a carbon. So ladies and gentlemen, this was your intro to organic chemistry. Hope you got it. Let me just tell you, organic chemistry is awesome. It gets really fun. So if you have any questions on your handout, let me know. I'll be here. But before we do, let me cruise right back up to the very top. There's one more thing I wanted to show you. So remember we did this stick structure originally, all right? And we were like, oh, here's our stick structure. Let me just draw it for you. It was a carbon double bonded to another carbon, and you had the hydrogens coming off the side like this, all right? What would the skeletal structure look like on this one? Well, remember you would draw a dot where each carbon is. There's a carbon, there's another carbon, and you connect them, right? That's just too big, all right? So you have your little dots. You connect them if you want to. And in theory, this isn't it because it's a double bond. This would be the skeletal structure, ladies and gentlemen, for this ethane molecule, all right? It would just be the 2 lines. You just go like this. Dude, it's equals. Yep, well, in chemistry, that's ethane, all right? Because you have a carbon, and then your hydrogens you don't draw. So this would be your answer right here, all right? So, ladies and gentlemen, that's it. Hopefully you understand everything, but again, I'm right here if you need any assistance. Have a good day. We'll talk to you soon.